All right. Well, good morning and afternoon, everybody. I'm going to turn my webcam on to say hello. Thank you so much for joining our webinar today on 3 obstacles to continuous testing and how to remove them. My name is Jamie Motherall, and I'm a functional testing specialist here at Parasoft. And on the line with us, we have one of my colleagues, Wilhelm Hawker. Wilhelm, did you want to introduce yourself?
Yes, hi everyone, Wilhelm here. I manage the solution engineering team at Parasoft, focused on our functional solutions, and looking forward to doing this webinar with you today.
Mhm. We have a great session planned for everyone today where we will be discussing the 3 most common roadblocks that we see that hinder a software team's ability to adopt continuous testing workflows and how to overcome those challenges. Now, before we dive in, some quick housekeeping. If your view of the slides or the demo appears to be a little bit blurry, please be sure to adjust the video resolution in your GoToWebinar window in your browser. And it also helps if you maximize the window to full screen, the presentation to full screen, especially during the demos. If you do have any questions or issues regarding GoToWebinar, please feel free to put them into the Q&A area at any time, and one of our colleagues will be reaching out to assist. All right, let's kick off with a quick agenda on what we have planned for you today. We're going to start with a quick discussion around the pace of software releases and how it has accelerated and that added pressure that it's created for testing teams. Then we'll dive into the 3 obstacles we want to discuss for continuous testing and how we can overcome each of them. Today, we'll be discussing how to build a testing strategy that mitigate these challenges, and we'll be showing a short demo as a part of the discussion on solutions and test strategy. Now, keep in mind, for the sake of time, we'll not be able to demo every one of the solutions we'll be discussing today, but you're always welcome to reach on out to Parasoft to request a more in-depth demonstration if you'd like to see more. Uh, then we'll finish up with a quick recap and take some questions at the end. Now, if you do have any questions throughout today's presentation, please go ahead, put them into the Q&A box at any time. We'll be monitoring those questions as they come in, and if it makes sense for us to answer it in real time, we will. Otherwise, we'll be sure to address all questions at the end of today's presentation. So, continuous testing. Continuous testing is a practice that goes hand in hand with the concept of continuous deployment. From the early 2000s until today, there have been trends toward releasing software as often as possible. And of course, automated testing is a key part of mitigating the business risks associated with frequent software releases. Wilhelm, in your experience as director of solution engineering here at Parasoft, I'm sure over the years of working with our customers, you've noticed this increasing pace of software releases.
Mhm.
As teams are increasing the frequency of their releases and running into testing roadblocks, what should really the audience expect in today's presentation and webinar?
Yeah, so as we explore continuous testing, I'd like everyone to keep the term scale in mind,
Hmm.
right? And so, how often your organization releases software is one way of thinking about scale that's going to directly inform how severe the obstacles we'll be discussing are. But there's also the scale of the software under test and the scale of testing that's being performed, which we'll be examining as well.
Hmm. And as we think about that increasing scale in software releases and the extra pressure this is putting on testing teams, I can't help but to also consider the fact that the complexity of the technological ecosystem is also creating further challenges for software teams.
Yeah, exactly. And this brings us to our first major obstacle I'd like to discuss today. As software has increased in complexity, the skill sets needed to automate and optimize testing have also increased. And not
Hmm.
every tester is going to have that required technical skill set and knowledge that they're going to need to be able to test these systems effectively or efficiently.
Hmm. And that's right. Working with our customers here at Parasoft, I've definitely noticed that many teams are very diverse when it comes down to their skill set and the technical knowledge they have. And as teams scale their testing practice to keep pace with the frequency of releases, new challenges are arising which can slow a team's testing velocity or can impact the stability of their automation. So beyond just the skills needed to create, stable automated test cases, teams also need to have the knowledge on how they can optimize their testing, and they may not have the knowledge on how to optimize testing once their testing practice has reached a certain scale or a certain maturity level.
Yes, and many teams, for example, will focus a large part of their automation strategy on UI testing.
Hmm.
And unfortunately, as the complexity of the application increases, UI testing alone is often insufficient to test the full functionality of the application within the constraints that you have. And so, as the test suite grows to include thousands of test cases, some of the common challenges we see with UI testing, like the brittleness of those tests in the face of application change,
Hmm.
the high test maintenance requirements or slow feedback loop, these all become more pronounced as the number of tests you're running increase. And so the challenge really becomes how to optimize testing after you reach this certain level of scale.
Hmm. Exactly. So, let's take a minute to talk about the challenge also of the increasingly software complexity. As we start to look at how modern software is being architected nowadays, we do start to see ways that we can optimize this testing process, right, Wilhelm?
Yeah, that's right, Jamie. And despite the scalability challenges of end-to-end or DOM to database testing, they are quite valuable, right?
Hmm.
They're valuable from the perspective of testing user journeys, critical paths, client-side logic, the various environments where the UI is running, like different browsers or mobile devices that need to be certified. So these tests are undoubtedly valuable, but they come at a high cost.
Yeah. So, Wilhelm, we do see a lot of Parasoft customers that address the testing scalability challenge by focusing heavily on the API testing. Um, can you tell us a little bit more about that?
Yeah, absolutely. So when we look toward the integration points between systems and middleware orchestrations, this is what everyone thinks of when I ask them about their API testing practice. And while these APIs are a critical part of the system architecture that has to be tested, that's often the extent of the testing I typically see when an organization tells me, oh yeah, we do API testing.
Hmm.
However, there's another opportunity for API testing that's often overlooked, and it speaks sort of to this how you can optimize your testing strategy to deal with the scale that we've been discussing. And so when I see projects where the front end is built with Angular, React, or similar frameworks, that's a strong clue that the application is architected with a degree of modularity where experience APIs are powering the features and functions presented in the UI. And
Hmm.
this is really where we have an open door to optimize the functional testing strategy, where a lot more functionality is tested directly through these experience APIs versus the UI. And so testing these end-to-end business flows through these front-end APIs has a lot of advantages like quick execution speed, low
Hmm.
maintenance, efficient root cause analysis, to name a few.
Yeah. So, API testing, it does provide teams with this really more scalable approach to test automation than in comparison to over reliance on UI testing. However, this kind of brings us back to that challenge on how to adopt a robust API testing strategy for these experience APIs when the testing team may be inexperienced with API testing or hasn't tried testing these experience APIs in the past. And this is really where AI can be applied to help teams with diverse technical expertise to easily adopt and scale API testing. So let's switch over to discussing the solution. The first technique that we want to cover today is adopting a lean UI test strategy. Now, a lean UI test strategy encourages teams to focus more on the API layers to validate business logic and application functionality at scale, while focusing UI testing on validating the user experience, the user interface, and critical paths. And really, this technique, it echoes back to that evolution of software architecture we were just looking at, right, Wilhelm?
Yeah, exactly. So as systems
Mhm,
become more distributed, more modularized, so too the opportunities to diversify the methods by which you're testing that business logic.
mhm. So let's show them what we mean. Wilhelm's going to take control here. He's going to go over a quick demonstration of Parasoft Soatest's AI-powered API test generation capabilities. And he's going to show how a team that is more familiar with UI testing can very easily shift their test strategy to create API tests for their experience APIs that we were just discussing.
Yep.
Take it away.
And so here I've got the Parasoft demo app. We're a camping equipment manufacturer in this scenario. We have products that we ship out to stores to stock their shelves.
Hmm.
And this app is built on Spring Boot. The UI is leveraging Experience APIs to go through the whole kind of workflow in the UI. And so what I'm going to do is use the Parasoft Recorder Chrome extension here to start recording my end-to-end scenario. And so, as we log in and we start going through the flow, all of these actions like, going into the product page, adding an item to the cart, this is all being kind of captured in the network traffic that's taking place between the browser and the application. And so these are all API calls, right, that are providing the functionality to this end-to-end flow that we're trying to test here. And so here we'll come in and we'll go through the order creation process. And if we think about, doing this with a UI test, it could be a lot of pages that we have to interact with, downloading images, um, working with all the data inputs. And so
Hmm.
we'll put in some numbers here. And so when I click submit for approval here, this is an order getting created in the system, order number 3. But it doesn't stop there, This is kind of an end-to-end flow. And so we have an approval user that comes in and checks the orders before they get, sent out and shipped. And so
Hmm.
now logging in as the approval user, um, we're modifying that order that got created, So you can think about those sequences of calls that are being made at the API layer to sort of facilitate this whole flow. And so I'll come back here as the original purchaser user, and I've got an update to the order. Looks like it's been approved, And I can check the details, Comments good to go. And so here at this point, I'm going to stop the recording so we can then see, how this kind of UI test flow that we just did gets represented as sort of an API scenario test. And so we'll give our test a name here. We'll call it webinar. And so when I click create test asset here, all of that traffic that was captured from the recording in the browser is being sent to Parasoft Soatest, where our AI is kind of processing through all of that traffic and then giving us an API test that we can look at and run. And
Hmm.
so now I'm showing you Parasoft Soatest. And here is that webinar test that we just recorded. And one of the nice things about Soatest is you don't need to have programming skills or development level skills to be able to do API testing. So all of these test clients that we're seeing here, this is all of that API traffic that was taking place as we were going through the scenario, right? And if I open up one of these test clients, you'll see that we have a nice UI for configuring an API test client. Everything from validating response data, interacting with databases, comparing data, all that good stuff is built in without having to write any code. But it's not just about taking all of this API traffic and giving you a scenario. With a lot of these types of end-to-end flows, there's going to be dynamic data, right? So for example, here at test 24, we're logging in as the approval user. Test 27, so this put request, this is modifying that order that got created. And so for this test scenario to really make sense, we can't hard code the order number because the order number is getting created every time we run the test. And sure enough, the AI figured out that, right, we can't hard code the order number, and we have this variable here. And so if I go look at test 23, right, post request on the orders resource, sure enough, this is when the order is getting created. And the AI recognized that there's some data in here that's relevant for subsequent test steps, right? So this order number, it automatically extracted the value, it put it into a variable, and it's looking throughout all of the API traffic for these opportunities to stitch dynamic data together so that at the end of the day, you have a test scenario that's pre-configured to sort of mimic the business logic of right the JavaScript that's running in the browser and doing these things, so that unlike our UI test that may take upwards of a minute to run, right, going through all those pages, downloading all the images, etc. Running the same end-to-end flow through the experience APIs, in this case took just 3 seconds to run. And if I come back to the application and refresh the order page here, right, sure enough, there we have a new order. It's in that final status, approved, right? It has the items that we had in here.
Mm-hmm.
And so it's able to, right, dramatically reduce the time that it takes to run through a scenario. And when I mention scale, it's about scaling, right, all those data permutations, the corner cases that you want to run through, as you're looping through all those UI tests. You can imagine, right, if a UI test takes 1 minute to run, and then you have, right, 60 different data source rows that are looping through different data conditions, right, now that one test takes an hour to run. And so, if you want to get through the same depth or robustness of testing and really test the functionality of the application that the UI is built on, right,
Mm-hmm.
you can do that same level of scaled out testing, right, using a data source, data driving these API tests, and getting through it a lot more quickly than if you were just using your UI test framework for, all of that scale of testing that you're trying to accomplish.
Mm-hmm. And I really love how this is really bridging that gap between the UI testing and API testing. For a tester who's not super comfortable testing the APIs, especially doesn't have the experience testing experience APIs or writing out API test scripts. The AI here really gives them kind of this start that they need to be able to transition into API testing.
Mhm.
Before we move from here, though, Wilhelm, we do have a question in the QA box that does
Mhm.
seem relevant. So we have someone here asking, if the application does not have a UI or the UI isn't feature complete, can this AI still generate API tests, or does the recording have to be from the UI traffic? You want to take that one?
Yeah, yeah, that's a good question. So what I showed in the demo here, it's really based around these experience APIs where teams are trying to overcome, those challenges presented by UI testing in their pursuit of scaling up their testing practice.
Mm-hmm.
However, we do have another application of AI through an integration with large language models where, similar types of API scenario tests can be created just from a service definition and the custom prompting where you kind of tell it what kind of tests you want to be created. So for earlier stage API testing, maybe where you don't have the ability to record live API traffic, AI is also there to help you in a similar way.
Mhm. So Wilhelm's gonna give control back to us for the slides, and just to kind of reiterate here, a lean web UI test strategy urges testing teams to focus more of their testing efforts on the API layers while minimizing again the UI testing, so that UI testing is focused on validating the user experience versus the business logic of the application. And really, by having the test automation strategy put more of an emphasis on these API layers, testing teams are able to overcome a lot of the challenges related to UI scalability. So Wilhelm, this makes a lot of sense, but many teams have highly invested in their UI testing strategy. So how can they adopt this shift without really sacrificing the investment they've already made in their UI testing framework?
Yeah, so Jamie, I think it's important for everyone to remember that we're not talking about replacing UI tests with
Mm-hmm.
API tests. We're talking about introducing these end-to-end API tests into the process to help teams scale the amount of testing that they're doing so they don't suffer from those scalability issues trying to do it all with UI testing alone.
Mm-hmm.
So thinking back to those data permutations, the corner cases, looping through those UI tests over and over again, that adds a significant delay and cost um, to the overall testing cycle. And that can really be shortened by testing more of this business logic at scale through these experience APIs instead. And
Mm-hmm.
so, you still want to keep and maintain good test coverage with your UI testing. The optimization here is really centered around that scaled testing that we've been discussing. And the good news here is our solution also includes a REST API. So you can inject this recording workflow into your existing UI testing framework
Mm-hmm.
without needing to manually play through every test case like I showed you today with the Chrome extension. You can kind of build it into your test framework, run through all your UI tests, and get a bunch of kind of corresponding API tests out of it.
Yeah, so this really kind of allows a team that has heavily invested in UI testing to inject that recording workflow into their test executions, and then generate very rapidly this complementary test suite for APIs.
Mhm.
Pretty powerful. All right. So let's talk about our next major obstacles for continuous testing, and that's going to be slow test execution time or slow testing feedback. So Wilhelm, I'd like us to add some numbers to this picture. You pulled a couple of Parasoft's large enterprise customers to just get a sense of what we're dealing with, and that comes from both small to large projects where there is this heavy emphasis on UI testing. Would you mind breaking down what your analysis revealed?
Yeah, sure. So for small projects or greenfield projects just getting started, they
Hmm.
might have 50, 100 tests that they are automating. As the scale of the projects grow up, complexity importance goes up. We've seen 2,000, sometimes way more than that. And so, these numbers were sort of a happy medium to work with. And for the average test duration, this one was trickier to nail down because there was such a wide diversity. Some tests were real fast, some
Hmm.
tests took, a long time to run through, right? Dozens and dozens of pages, for example. But everyone kind of felt comfortable with a minute and a half as, a workable number for an average. And so where we end up with the scale of testing here, it's test execution times overall that can span an hour or two up to a couple days, sometimes even longer. Right? We've had a customer that took weeks to get through regression testing cycle,
Hmm.
which isn't uncommon. So, that can be really problematic if you're trying to adopt, continuous delivery, continuous testing, and, development is promoting builds into the QA environment, daily.
Yeah, it's very slow feedback. So next up, we have a surprise poll. Don't worry, guys, it's just one question, really quick. So I'm going to launch it. You should see that pop up now. So again, one question, how long do your full regression test runs take? So we just want to get a general sense, select the one that most closely follows your organization. Maybe it's below an hour for total regression suite execution time, below 4 hours, below 8 hours, below 24. Maybe you're, in that same boat as the customer we were just talking about, which is above 24 hours to run their full automation or full regression test jobs. All right, we're getting a couple responses on in. We'll give everybody just a few more minutes here. We're at about 40%, 50%. All right, just for sake of time, I'm going to close it right now at the 50%, and let's take a quick look at what people were saying. So it looks like we do have, some people that are already optimizing or finding ways to optimize their regression suite execution times. They've got it below 1 hour. It could also be, your test suite hasn't yet scaled to the extent where you have thousands of test cases. We do have a couple that are, looks like it's about 4 hours, 8 hours. So, again, that is a big chunk of time that you're still waiting on in order to get that testing feedback when changes occur.
Mhm.
Wilhelm, is there any comments you would have here?
Yeah, it's not surprising to see larger amounts, right? So from 4 to 8 hours, if you think about that,
Hmm.
development isn't really getting feedback until the following day. And then there's
Hmm.
there's other strategies people employ, like parallel test execution, to try to put hardware to speed things up. But ultimately, it looks like, with these longer test execution jobs, it can be a challenge to right, get that incremental testing done, right, to keep your test automation flowing, during the sprint, let's say.
Yeah.
And so I'm excited to sort of cover the next topic we have for us here that can help with this.
Hmm. All right. So let me just double check that I'm still sharing my screen. Okay, great. So this brings us to the next technique that we want to discuss, and that is reducing the testing scope so that teams can focus on new functionality or areas of the application that have changed. Wilhelm, you want to break this down for us?
Yeah. So, let's say we're adopting lean UI testing principles, but we're still buckling under the scale of testing
Hmm.
that's required of us when trying to hit our continuous testing targets. And so this is really where the second technique comes in. When you have a huge suite of regression tests in the order of thousands, right? And these are these DOM to database, right? Long running tests, takes hours or days to run. You're inevitably going to run into limits with how often you can successfully validate and promote new builds that are flying out of development. And so, in a perfect world, you want to run every test with every incremental build. And that way, you can get maximum confidence that you're catching issues early, catching them before they go to production. But this can put a huge strain on your resources, right? Both human and machine. And so, what testing teams do is they'll develop processes to try to optimize how much automated testing they do in between these full regression sessions, right? Which may only happen, once or twice per release cycle. And so they're trying to strike a reasonable balance between, the resource constraints they have and how much testing they can sort of handle. And what some teams I've spoken with do here is they'll try to implement processes like a tagging based system or kind of an arbitrary commit suite of, these are the most important tests to run to help them filter down what tests they run. But inevitably, this leads to missing things until later in the process which can cause bottlenecks to your release velocity. And
Mm-hmm.
so, what we're here to tell you is that there's a better, more precise, and most importantly, totally automatic way of reducing this testing scope while still maintaining the fidelity of kind of the regression testing you're expecting. And it all starts by measuring code coverage. And so we know that many development teams measure code coverage from unit testing. It's easy for them to do. It's a great way to start with the metric. But as we've been discussing today, the majority of testing that's being done often happens well above the unit level.
Mm-hmm. And Wilhelm, this is where many teams, I think, encounter challenges. When it comes to, yeah, higher level functional testing, this type of black box test, measuring code coverage here can be very problematic, can be just really challenging for a lot of teams.
Yeah, that's right. And while measuring, functional test coverage is doable with open source libraries and some elbow grease,
Mm-hmm.
the optimization that we're talking about here, it requires code coverage for each individual test that's being executed. And it has to also support, right, the modern distributed systems like microservices architectures, which can make it much more complicated to accomplish. We can't just measure code coverage of the overall testing job to get there.
Mm-hmm. So this brings us to test impact analysis. So we want to just take a moment to talk about how this works. Like Wilhelm said, it all starts with mapping what code coverage you're getting for each individual test case that's being executed. Next, we do a code diff from a baseline build where you last ran your full regression test suite. Now, this could be yesterday, a few days ago, last week, or even during your last release. Really, the baseline is up to you to decide. And as a result, what we're able to do is calculate the exact set of tests that are impacted by the code that changed from that baseline build. And we actually do this with method level precision for your code, so it's highly accurate. So at this point, I want to turn it back over to Wilhelm. He's going to take control. He's going to show you a demonstration of test impact analysis using one of our applications, demo application that's built on microservices. So we'll be looking at microservices testing for this. Go ahead.
All right, one moment. Okay, and so the application we're looking at today, it's the Spring Pet Clinic microservices project.
Mm-hmm.
Pretty popular project. Spring Boot developers will probably be familiar with it as they're getting started learning Spring Boot. And so this is a containerized distributed system. It's got kind of four key microservices in the system. So an API gateway, a vet service, a visit service, and a customer service. So these four key services kind of represent the entire system under test. And so what we're looking at here is Parasoft's reporting and analytics dashboard, DTP. And so we've got unit test code coverage that we're collecting from the unit tests in this repo. But we also are measuring the functional test code coverage. So we've added some Selenium tests to the project, and we're measuring the code coverage against each individual microservice as that kind of system level test with Selenium is being run. And so that kind of gives us, full visibility into what code is covered versus not covered, right? Kind of covering a broader scope of all the testing that's being performed. And so if we look at what tests we have, there's going to be um, five functional tests here. So there's navigate test, pet test, register owner and pet test, vets test, and visit test. So we have five functional tests that we're running. And as Jamie mentioned, right, this test impact analysis, it's based on comparing against a baseline, comparing against what's changed.
Hmm.
And so our solution is built around that kind of change-based testing concept. Right here, we can see, from a target build to a baseline build, right, from V2 to V1, what code changed. And so if I kind of scroll down here, we have some widgets that represent that. So in each microservice in Pet Clinic, in the latest build, there have been some code changes that took place. And so the question is, okay, well, which of our functional tests should we be rerunning based on these code changes, right? Development is promoting builds into the environment every day, right? In the scale of thousands of tests, it's sort of, what tests do we run? What tests do we focus on to maintain, to get our in-sprint test automation running smoothly? And so next, I want to spend a little time kind of going over the entire process. Like I've got a Jenkins pipeline here that's sort of the full CI, CD, CT pipeline. So it starts with building the code into binaries, creating Docker images out of it. This is a Dockerized project. And then in that build phase, we have sort of an integration point where we collect some metadata on the executable code to start calculating what that code coverage metric will be. Then those binaries get deployed into containers. And here we have another integration point where we inject our coverage agents to instrument that running code of the application, right? Like we want to be able to measure what code is actually being executed while those Selenium tests are running. And so we have a coverage agent for each microservice in this pet clinic deployment. And we have some customers with 50, 60, even hundreds of microservices in their overall system under test. And so being able to measure code coverage across that distributed system is more important than ever, looking at how popular it is to, going from monolith to microservices and how popular distributed systems are. And then the last step here, the test phase, right? So the test framework interacts with our system, right? So that we can build that correlation between code coverage and test cases, get that mapping to sort of enable the test impact analysis workflow. So kind of three key points where we inject ourselves into the pipeline: the build phase, the deploy phase, and then the test phase. And so once we're injected into the system, then the question becomes, okay, how do I automatically parameterize my test framework with only the tests that I should be running based on what code changed from some baseline build that I performed tests against? And so here it's an API call you make and it returns the set of tests that are impacted. And so I've got it highlighted here. We have pet test and navigate test. So 2 out of those 5 Selenium tests where we had code changes between the builds, we only need to run 2 of them. And yeah, Pet Clinic, it's a small project, not a lot of tests in here. But as we'll see in what Jamie's going to cover next, this really compounds as you start looking at larger projects, huge testing jobs that take hours and hours to run. So I'll switch it back over to you, Jamie.
All right. So, as Wilhelm said, we want to next talk a little bit about what is the impact when your testing suite is a larger, large scale. So, these trend graphs come from one of Parasoft's own development teams that were facing similar testing scale challenges. On the left, we've got a trend graph of the full regression suite from one of our projects internally. It's got 4,000 test cases associated with it. On the right, we see how many tests were run with each incremental build when test impact analysis was turned on. And we can actually see a variable set of tests that were intelligently selected because they validate the specific code changes in that build. If you notice the y-axis on the graph on the right, there's actually a 0 missing. So this team on average was seeing test jobs that contain 50 to 60 or so tests per build when the full regression had over 4,000. And remember, that baseline you compare it against is really up to you.
Yeah. And so this ends up being a great technique for in-sprint testing because not only does it speed up the feedback loop to development, you can actually get functional test runs into that, quick iterative build process. Not only does it reduce the infrastructure burden on your DevOps pipelines, but most importantly, it reduces the how many tests you need to maintain for that given time period when you're looking at doing this incremental testing.
Hmm.
So you can really start focusing on the maintenance of that subset of tests that are relevant in each incremental testing period. And that can be a huge boost in helping you on that journey towards continuous testing.
Exactly. So we want to now talk about the last obstacle to continuous testing workflows, and that's unavailable or unstable test environments.
Yes, and so test environment challenges, right, they're made worse by the complex distributed system trend we've been discussing.
Hmm.
And they're often a source of heartburn when you're trying to shift left your testing, scale up your continuous testing strategy. And test environments, they become brittle in four distinct ways that we call the ABCDs of service virtualization. And so the first one, A, for availability. Continuous testing, it requires stability and consistency. And many organizations, they struggle with their QA environment stability, right? Standing up another environment, maintaining it, delivering near 100% uptime can be very unrealistic in these sort of
Hmm.
lower environments. And so we know that these downtimes will directly impact the ability to test anytime, test anywhere, and it leads to poor quality outcomes and delays to the release.
Hmm. The next we want to talk about is behavior. This use case represents your ability to effectively test beyond the happy path. So, what happens if a downstream service has an error or starts responding very slowly? Are you testing negative rainy day scenarios that are difficult to simulate in your test environment? These are all cases where you really need to inject your own simulation logic to control the various dependencies that might exhibit these behaviors to ensure your application is resilient to these chaotic things that can happen in production.
Mhm. So next, cost. Simply put, standing up and maintaining an environment is not free,
Hmm.
and external dependencies add to that cost. The more users you have, the more tests that you run, the more those costs will scale, and that can conflict with your operations budget. And so when your test environment needs scale beyond the resources you have allocated, that's where you start making compromises, right? Shared environments, shared data sources. And this invariably leads to, again, delays, productivity losses, and overall lower project quality.
Hmm. And that last one we want to talk about is data. Test data in a test environment. I mean, it can almost be like a game of Jenga. People start removing pieces, adding pieces, and before you know it, you've got this messy pile that makes predictable, repeatable regression testing almost impossible. And this problem gets amplified when you have shared test data, shared environments. Once data is consumed, it may no longer be used for other tests until those changes are reverted, or there can be data conflicts that impact various teams in that shared environment. And these issues can waste a lot of time when there are a lot of moving pieces in your test environment, really impacting your ability to test continuously. So, in the context of testing, let's explore the impact environment challenges present for testing teams looking to run tests in continuous automation. We're going to start with our happy QA testers who are tasked with creating and running end-to-end integration tests against their application under test to prepare for an upcoming release. Their application has a web UI in this scenario, and their end-to-end test is driven through that user interface. Under the hood, their application is constructed of APIs that are like little puzzle pieces. So they're connecting in different ways. They're communicating by passing data through the various service layers. And their application has a front end or experience APIs. So their browser actions are directly interacting with experience APIs that are passing the request to other backend APIs, and then also communicating with an external or a third-party API, which could be controlled by another application team or by a partner company. Now, as long as the services, internal and external, all remain live and stable, that end-to-end testing should pass, and the testers should receive the expected result from their test execution. However, what happens when one of the external or internal services suddenly goes down? In this scenario, there's many reasons that this endpoint could suddenly become available. We just talked about the ABCs. I mean, it could be this API schema has changed. The API could just not yet be developed yet. It could be simply that they don't have access to that API when they need to test against it because it's controlled by a third party. Yeah, either way, the result is the same, and the test case fails, and the testers don't get the expected result. And now they really must allocate a lot of time to analyze the test to determine the root cause of failure. And in this case, it isn't an issue or a defect with their application under test, but the problem really lies in their test environment. So the QA team has now wasted valuable time to determine the cause of the failure. It's now blocked from running their regression test because that external API that they need to test against is not available. And this has really hindered their entire ability to run their tests in continuous automation and get continuous feedback from their testing. So this is where service virtualization steps in. By creating a virtual simulation of that unavailable service, the testing team can test against that simulation instead of the live service. And in that way, they're able to clear the path and roadblock to their testing efforts. They can test where, when, and as often as they want, allowing the team to eliminate testing wait times or downtimes due to offline services. And this increases their overall test velocity. So, Wilhelm, from your experience working with our customers, what are some common ways that an organization can get started with service virtualization when it's a new concept for them, but they resonate strongly with the challenges we just outlined?
Yeah, that's a really good question, Jamie, because I've seen organizations successfully approach this in several ways.
Hmm.
The initiative could be led by development. They're going to have needs that stem from parallel development challenges, right? A client team needs, right, a backend to build against, and that backend API may still be under development. And so these developers will often script their own API mocks, their own simulations, but the usefulness of those mocks often doesn't extend past the needs of those developers. And so
Hmm.
ultimately there's limited value in the time investment that they're putting into that. And so I've seen them adopt Parasoft where developers end up being the early adopters. And due to the user-friendly scriptless tooling that we provide, QA then follows by reusing and extending those same virtual services that the developers created and using them for their testing needs as they're trying to focus on the blockers that are preventing them from accomplishing that shift left or continuous functional testing in the earlier stages of their process. I've also seen service virtualization initiatives that get led by performance engineering teams. And so
Hmm.
performance environments, they're incredibly expensive, and there's a huge ROI in being able to simulate parts of the environment that are not changing or outside of the application under test. And Parasoft Virtualize has been proven to be highly performant and dependable for the unique requirements that stem from these performance teams where they're conducting high throughput load tests. I've also seen center of excellence models where a small team gets trained up to become domain experts in service virtualization, and then they sort of become an internal service to other application teams that want to leverage the technology
Hmm.
to unblock themselves in the variety of use cases that are making it problematic for them to, accomplish continuous testing or shift left testing. And then eventually that service virtualization usage grows where there's a natural federation, right? And application teams start taking it into their own hands to drive the virtualization that they need, building and maintaining it into their own pipelines themselves. And then the COE kind of becomes, right, first line support and internal training to the organization. And then
Hmm.
lastly, it's also possible for QA to be the trendsetters here. We have a learning mode feature that provides an extremely hands-off approach to service virtualization, and it allows non-technical teams to have just a brief collaboration with DevOps, and then they start reaping the benefits of service virtualization right away for very low effort. And so this can end up being a fantastic way to scale across the enterprise quickly and giving various teams a taste of what's possible and then letting them organically develop the internal expertise as their requirements to simulate more complex use cases like CRUD or stateful virtualization that start popping up.
Hmm. And
Mm.
working with our customers as well, I've noticed that oftentimes it's a combination of these approaches. Your development team might get started with the tool. For the QA team, they set up that center of excellence, but then you also do have some of the QA team taking advantage of the learning mode features. So it really comes down to what you want at the end of the day when it comes down to who owns this your test strategy. And I highly recommend reaching on out to us, set up a call if this is something you're interested in. We can have a discussion around your testing needs, and our team will have help you to actually craft that test strategy. Another thing that pops into my mind as we talk about ways they can get started, Parasoft does offer a free version of our service virtualization solution. We also offer a 14-day free trial of the full product as well. I'm going to put into the chat for you guys a link actually to where you can download that free version. So I'll send that on over to you guys to take a look at, and that'll go into it for you. We've got just a little bit of wrap up to do. Um, there we go. So again, thank you, Wilhelm, for those insights into how to get started with service virtualization. So doing a quick recap. So again, the obstacles we discussed today are the lack of technical expertise in how to shift testing so that the test strategy is more scalable and will provide faster feedback. And again, we do this with AI-powered API testing solutions that can help teams to really bridge that gap between the UI and the API, adopting that lean UI test strategy. And we discussed how AI tools can be used to help teams easily generate suites of API scenario tests to validate business logic. Then we discussed unstable or slow test executions and how once a team reaches a certain maturity level, their test suites will grow to the point where testing feedback is slow due to the time needed to execute full regression suites. We talked about how teams need to reduce that testing scope and looked at how Parasoft Test Impact Analysis can plug into any automated testing framework to accelerate testing cycles and that feedback loop by limiting the scope of testing to the areas of the application that have been impacted by change. And then finally, we discussed the challenge of these unavailable or unstable test environments, how that hinders a team's ability to successfully implement continuous testing workflows. We didn't have a chance to demo this today, but I again highly recommend reaching on out to us to request a demo. By adopting all of these different solutions to mitigate these challenges, teams can really remove the roadblocks that they have and successfully implement continuous testing workflows. Now, at this point in the presentation, I'm just going to give everybody a few more minutes to go to the QA section, add in any questions that you might have. We will be reviewing those momentarily. I do see we have some questions already in there. In the meantime, we do have some additional resources we'd like to share with you in case you'd like to dig deeper into our solutions and how we support continuous testing. The links to these, I'm going to be adding them to the chat as Wilhelm starts looking at the questions that we have. But we do have a white paper I recommend on continuous testing for DevOps, how to evolve beyond simple automation. And then also while looking at testing solutions, I do always recommend reading what the analysts say regarding tool selection. Here we have the recent GigaOM report on API functional testing, and this rated a collection of popular testing tools, including Parasoft, and analyzed their capabilities for everything from API testing, test management, API mocking or service virtualization, and even test data generation and management. And all of these really connect to that story of how to enable continuous testing. So this can be very helpful if you're looking to look at what other tools, what other vendors are out there that can support you. This provides you a nice rundown of the different vendors on the market, and it will give you insights also into how analysts recommend looking at different testing solutions and what they add into their equations when rating testing solutions. So let's dive into the questions here. Let's see. So we did have one that is about our AI. So they are asking, is our AI all LLM based, or can it operate on-prem? Do you want to take that, Wilhelm?
Yeah, sure. So what I demoed today is not based on an LLM. It's kind of runs locally within your network. We do have optional LLM integrations across our product suite. So, some of our customers have varying degrees of acceptance in terms of their policies to use LLMs. We support OpenAI and Azure OpenAI today. And so you don't have to use those LLM features if you don't want to. Like for example, the one I showed today, that's sort of our own kind of on-prem running AI as part of the product. And so, yeah, no outside connection needed there.
Mm-hmm. Very good. So let's see. Got a couple questions. Um, let's see. I'm just sorting through them real quick and I clicked away for a second. Give me just a minute to get back. There we go. This is just a quick question about CI/CD. This is easy. They're asking if we can integrate to Jenkins. You want to talk about that real quick?
Yeah, absolutely. We have a command line interface that makes it easy to run in any CI/CD platform,
Mm-hmm.
Jenkins, Azure DevOps, um, um, Bamboo, TeamCity, and we also have plugins for those platforms as well. So integrating our reporting into those systems is also available.
Mm-hmm. And then this is a good question as well. APIs still experience change. So how can I keep up with test maintenance with APIs?
Yeah, good question. So, that's a common challenge when teams are trying to have a robust API testing strategy. They develop a lot of API tests, and then the next version of the API comes out, a bunch of breaking changes in the schema, and so then they go, gosh, how do I, refactor all of my API tests quickly, right? And it can be a weeks long process. And so one of the capabilities we have in Parasoft SOA Test, it's called Change Advisor. And so you can basically create a mapping between the two schemas and then do a bulk update across all of your API tests to significantly reduce the time it takes to sort of do that update whenever there's changes in the API.
Mm-hmm. And then one more question here. I think that's all we have time for, and then we've got to end today.
Mhm.
But this one is asking about test impact analysis. They are asking for clarity. Can we support Playwright? Do you want to clarify kind of our support there for test impact analysis and what frameworks we support?
Yeah, absolutely. So it's really any test framework, right? It could be Playwright, it could be Cypress, Selenium, even a commercial UI testing tool. And really what it is we support Java and .NET as far as the backend languages that we have coverage agents for. But on the test framework side, it's really any test framework you have.
Mm-hmm.
We'll work with the test framework, and as long as it's a Java application or .NET application on the back end, then we can measure the code coverage of those systems and enable the test impact analysis.
Yeah, perfect. Well, again, I think that's everything we have time for today. We really appreciate it. I know this was a little bit of a longer session. We had everybody looks like it. They lingered on. So we appreciate you guys so much. If you do have any questions, again, feel free to reach on out to us. We're always excited to talk about testing, test strategy, how we can help you to optimize. Again, in the chat, you've got links to all of those resources, as well as a link to our contact me page where you can reach out to us to request a meeting to discuss your testing challenges and help us to customize a demo specifically for you. Okay, that's a more in-depth look at our technology. Again, thank you, everybody. You have a great rest of your day, great rest of your week, and happy summer and happy testing. Bye bye.
All right, bye.